Lastly, we have to know the horizontal forces to know the value of reaction at Ax. Since there is no value for horizontal forces, so our reaction at Ax is equal to 0. After we find out all the reactions in the support, we have to move on to shear force calculation in order to draw it. First, we have to identify the forces on the left and the right side of the diagram. VL is equal to 0 kilonewton. Force at the right side is equal to 0 plus 10 equals 10 kilonewton. And up to the force of the right side of the B. 10 minus 10 is equal to 0 kilonewton. Then we have to find out its bending moment calculation, wherein we have the moment of each stations or parts of the beam. Moment at A is equal to 0 kilonewton meters. As you can see in the diagram, there is no specific force that is loaded on the part of section A. Then moment at C is equal to 0 plus 10 times 2 is equal to 40 kilonewton. Then for moment B is equal to 40 minus 20 times 2 is equal to 0 kilonewton meter. And that is the diagram shows the shear force and the bending moment. Let's move on to an example of influence line. Draw the influence line for A, the vertical reaction at A and B the shear at B, and C the moment at B. Assume A is fixed. So in the diagram, there is a support reaction at A which is fixed support. In this problem, we have to draw an influence line. Influence line for RA is 1. Influence line for RB is equal to change in 1 plus change in 2, 2/3 plus 1/3 is equal to 1. Then of course, influence line for moment at B is equal to negative 2 times 2 over 2 plus 2. Negative 4 over 4 will be negative 1. And that is the influence line for the beam. Now we will continue our topic. For this time, it is trusses. We have to find out its reactions and influence lines. There are two methods in order to know the axial force of the trusses. The method of joints involves successively isolating each joint in a truss system and determining the axial forces in the members meeting at the joint by applying the equations of equilibrium. We have here an example problem. Using the method of joint, determine the axial force in each member of the truss. First, we must know if it is internally stable or internally unstable. Since the trusses are fully supported, it is internally stable. Then we need to find out how many reactions are there in the truss. Since it is supported by a ruler and a hinge, wherein a ruler has 1 reaction and the hinge has 2 reactions, summing it all up, this structure has 3 reactions. There are 5 members, 4 joints, M plus R, 2J, M, pi plus 3, 2 times 4, 8 is equal to 8, which states that it is statically determinate externally. Since it is statically determinate externally, we have to move to solutions in finding axial forces. First, solving for support reactions. Summation of moment at A is equal to 0. 20 times 4 minus 12 times 3 plus 8 reaction at CY is equal to 0. So, given this, we'll get CY is equal to negative 5.5 kilonewton or 5.5 kilonewton, where the first is in downward. Summing up all the vertical forces is summation of y is equal to 0, wherein AY minus 5.5, the value that we get from CY, plus 20 is equal to 0. AY is equal to negative 14.5 kilonewtons. After that, we have to get the value of A of x in order to complete the reactions. By summing up summation of F of x or horizontal forces, negative A of x plus 12 is equal to 0. A of x equals to 12 kilonewton. Since we have solved all the supports reaction, let's move on to determining the axial forces in each member of the truss. At joint A, to find the force on AB, we have to sum of all the vertical forces is equal to 0. Force of AB is equals to 24.17 kilonewton. While forgetting the force in AD, we have to sum of all the horizontal forces to 0. Negative 12 plus force AD plus force AB cosine of 36.87 degrees equal to 0. We'll get force of AD is equal to negative 7.34 kilonewton. There is no vertical forces, so by summing of its vertical forces, we will get force of dV is equal to 0 kilonewton. But by summing up all the forces horizontally is equal to 0, negative force of dA plus force DC equal to 0, FDC equals to FDA is equal to negative 7.34 kilonewton. As you can see, force DC and force dA is the same to each other. At joint B, by summing up all the horizontal forces is equal to 0, we can get the force of BC. So, negative force of AB sine of 53.13 plus force BC sine 53.13 plus 12 is equal to 0. Substitute the force AB, which is 24.17 sine 53.13 minus 12 divided by FBC sine of 53.13, and we will get the force of BC is equal to 9.17 kilonewton. Methods of section. This method involves passing an imaginary section through the truss so that it divides the system into two parts and cuts through members whose axial forces are desired. Member axial forces are then determined using the conditions of equilibrium. The diagram is an example of methods of sections. We have here an example problem. Determine support reactions using the method of section. Determine the axial forces in members CD, CG, and HG of the truss. So first we must know its determinacy in order to solve it. It must be statically determinate externally. So the diagram or the truss is internally stable. It is supported with a hinge and a ruler. So it has a total of 3 reactions. And member 13. Joints 8. So we must solve it. M plus R 2J. 13 plus 3. 2 times 8. 16 is equal to 16. So it is statically determinate. After knowing its determinacy, we must move on to finding the axial forces. We will now move to determine support reactions or solving for the support reactions, wherein AY is equal to FY is equal to 160 divided by 2 is equal to 80 kilonewton. With the summation of horizontal forces is equal to 0, we can get that AX equals 0 kilonewton since there is no horizontal forces. Then we will proceed to the method of section. The truss is cut in half by the moment of G is equal to 0. Negative 80 times 6 plus 80 times 3 minus force of CD times 3 is equal to 0. We will have force of CD is equal to negative 80 kilonewton. That's why the answer is force of CD is equal to 80 kilonewton, which is compression. Finding force at HG by the moment of C is equal to 0. Negative 80 times 3 plus force of HG times 3 is equal to 0, wherein the answer will be force AG is equal to 80 kilonewton tension. Then, by summing up all the vertical forces, summation of Fy is equal to 0. 80 minus 80 minus force of CG cosine of 45 is equal to 0. Then we will have an answer of 4 Cg is equal to 0 kilonewton. So we have here an example problem for an influence line for truss. The diagram shows a moving load. That's why we will draw the influence line of DJ. First, we must determine the path of travel that will allow the load to move. Calculate when the load is at P, C, D, and E. At point A and F, the load is 0. So our influence line will start with 0 and ends with 0. We'll use the method of sectioning in order to know the value of the support reactions. After we know the value of support reaction, we then plot it in the diagram. The plotted points will be connected to one another, and this is the influence line for DJ. So the solutions you see is an example of how we will solve the support reactions. This is only the concept on how you solve for support reactions in the truss. These are important steps in order to know how to plot and draw the influence line for truss as well as on beams. The use of sign conventions are also important in this kind of problems.